Today we are going to start with mass, weight, density, and pressure over there. And I will also add with mass and weight to the momentum also. And today our topic is related to subtopics of dynamics over there. And first of all, the word mass, if I am going to define this in a proper wording over there, then I will say quantity of matter present in a body, present in a body is called mass, and it is measured in kilogram by using a device named as physical balance or electronical balance over there. Physical or electronic balance. Electronic balance over there. This mass is also determines the inertia, and inertia of a body is being measured with the help of its mass over there. And if I go for it towards the weight, mostly whenever we visit to market, we use this word weight to measure the mass of the body. But in physics, in scientific terms, we use this as a gravitational force acting on a body, and this gravitational force is measured in newtons. And if I am talking according to the reference of Earth, then I can say weight is equal to gravitational acceleration multiplied by mass. M is mass of body, and G is gravitational acceleration, having its value equals to 9.81 meter per second square. This is gravitational acceleration. It varies from one planet to another planet over there. If I give here a comparison between mass and weight, I will say here that if I take here mass and I am taking weight over here, according to definition, as I said, it is quantity of matter present in a body, and it is gravitational force on a body. Gravitational force acting on a body. It is measured in kilograms as its unit in SI based units like that. It is called having unit Newton, or in SI based unit having kilogram meter per second square. If I use the formula for this one, I use here M is equal to W over G, means weight over gravitational acceleration over there. And for weight calculation, I use formula W is equal to mg. It remains constant if I go on the surface of Moon, I go on the surface of Mars, I go on Earth, then it stays constant on all planets. Stays constant. It varies because when I change the planet on the Mars, on the Moon, on the Earth, G is going to change its value. Like it is 1.62 for gravitational acceleration on the surface of Moon over there is being taken over there. So it can vary on that case. It is measured by physical balance and can also be measured by electronic balance over there. It is being measured by Newton meter or by spring balance over there. So it was a little bit comparison between both mass and weight over there. And if I take this mass with my velocity, then I will move towards momentum over there. Momentum. Momentum is basically, I can say, quantity of motion. Quantity of motion of a body is called momentum. It is vector quantity and it has its unit as kilogram meter per second. For example, if I say that I want to go for mathematical expression for this, then I say momentum mostly represented by symbol P over there, and momentum, then I will say it is the product of mass multiply velocity over there. Means mass into velocity. On the basis of this, I am taking its unit kg meter per second. I will also introduce its unit as Newton second. How that comes, I will explain in the section of impulse over there. And if I talk what is momentum, let's suppose there is a body which is moving, having mass m, moving with initial velocity u. After some time t, it gets its velocity to v, staying the mass m as it is again. Then I will say, consider there is a body which is moving with initial velocity u. A force F is applied on it as an extra force over it, and it starts to move to increase its velocity to v in time t over there. Then I will say there is a change in momentum over there. Change in momentum is over there, and change in momentum. If I talk about change in momentum, then I will say final momentum means PF minus PI, or I can say final momentum minus initial momentum over there. Means change in momentum is equal to PF minus PI over there. Then I will say it is MV minus MU. And the reason of this, why I am going to explain this, if my body after getting the force is changing its direction, means velocity is changing its direction, then change in momentum will come with MV plus MU. That will be added if change in velocity is happening. And in that case, we will say that should be added, or it is bouncing back. Bouncing back over there. Then we can say it should be taken in this form, that change in velocity should be taken as mv plus mu as change in momentum over there. But if I am going towards body is not changing its direction, like while playing the snooker over there with the white ball, is someone is hitting and ball red one is going in the direction of that one, then I'm going to take PF minus PI as my change in momentum over there. So from here, if I go to derive the force and momentum relationship in the form of impulse, then I am saying delta P is equal to mv minus mu. I am dividing by t on both sides over there. Then I'm getting what? I'm saying that I'm getting delta P over T is equal to M into V minus U over T. And according to the definition of acceleration, I know that V minus U over T, rate of change of velocity, should be taken as acceleration. So it is ma. And according to Newton's second law of motion, I can say this is equal to force over there. So from here, I can say F is equal to change in momentum, change in momentum delta P. I'm taking here delta P over delta T or T like that. And if I say this T is coming towards force, then F multiply T is equal to change in momentum. I can say mv minus mu over there. So, for example, some athlete is going to hit the football with his legs force F and his foot is in contact for time T. Then initial momentum, which is ball is lying at rest over there, and the velocity and mass of that ball getting in product. So it is called impulse. And this impulse is being taken in this form. I can say it is equal to change in momentum. It is having the unit as Newton second because force is giving the unit Newton and time is giving the unit second over there. So Newton in second can be taken into account for getting the relationship between force and momentum relationship over there. For this explanation, now I should move towards law of conservation of momentum. Law of conservation of momentum. As I say over there, let's suppose there is a body that is having mass m1. There is a body that is having mass m2. And it is moving in the direction this v1, u1, and it is moving with the velocity u2. Then there comes a point over there where they both come in contact because u1 is greater than u2. They come in contact over there as m1 and m2. After collision, this starts to move in the same direction, but different velocities are, I can say this is moving in this direction and other one is moving in this direction. And here it is having mass m1, m2, but having the velocities as v1 and v2 after collision. So I can say in an isolated system, in an isolated system where no external force, no external force acts on body, if in an isolated system where no external force acts on a body, the initial and final momentum remains conserved. Initial and final momentum remains conserved over there. And if I apply this situation in the form of mathematical expression over there, then I will say here that initial momentum is m1 u1 for first body plus m1 u m2 u2 is equal to m1 v1 plus m2 v2. So this was your initial momentum and this was your final momentum. So in an isolated system, we can say law of conservation of momentum is going to hold and body is going to remain as in equilibrium, we can say. And in a system, momentum remains conserved. In as I said, they are colliding. So it means there should be a collision. Collision can be of two types, elastic and inelastic collision over there. I'm saying here elastic collision. The collision between two bodies where momentum and kinetic energies of body, kinetic energies of bodies remains conserved. For example, you are throwing a ball on marble surface and it is bouncing back to the same height from where you are throwing it, then it means momentum and kinetic energy is remaining conserved. Are the gas molecules stored in a container um and at a constant temperature? What will happen? The molecules are colliding with each other of gas molecules. Molecules of gas molecules are also colliding with the walls of the container. But the temperature is constant, so their momentum and the kinetic energies of the molecules, which is directly proportional to temperature, remains conserved in that case. Such type of collision is called elastic collision, and the other one is inelastic collision, in which we can say inelastic collision is a collision in which I can say uh, the collision between two bodies, the collision between two bodies, the momentum or energy remains conserved. Between two bodies, the momentum or energy does not remain conserved. In this case, I will say here, sometimes it happens that you say, sir, there is momentum conserved, but energy is not conserved, or energy is conserved, momentum is not conserved. But in that case, we will say that that collision is inelastic. For example, your ball falling on a sandy surface. What will happen? Maybe it will not get height of even 10 centimeter like that. So that case is called inelastic collision. Or you are having the gas particles in a container, but you are also increasing the temperature. When temperature is increasing, then definitely we can say that kinetic energy of the molecules is increasing, even though momentum is conserved in that case. But kinetic energy, because of the increase of temperature of the cylinder over there, is increasing the kinetic energy of the molecules. That is not conserved over there. Such type of collision is called inelastic collision over there. After that, I am moving towards density and pressure over there. So in that case, I will say here density. Density is basically, we can say, density is mass per unit volume is called density. Its unit is kilogram per meter cube, and it is a scalar quantity. And according to mathematical expression, we can say density is equal to mass over volume. And for this case, I will say mass is measured by physical balance, and volume is measured by if you have some regular shape, then we can say it can be measured used by a formula. Or if you're not having any regular shaped body, then in that case, for irregular shaped body, you will take a small beaker over there, or maybe you are taking a volumetric cylinder over there, which is having uh, calibrations over there according to their volume over there. And you are filling this with some amount of water. Then you dip your body. What will happen? It will, when you get the body over here, what will happen? According to its irregular shape, what will happen that there should be an increase in volume, delta V. Then the initial building is having value V1, and that is V2, and change in volume will give you V2 minus V1. That will be the volume of irregular object, which will be later on placed in place of volume formula in the form of density over there. That can be calculated using that formula over there. So overall density is mass per unit volume, and for solids density is high, liquid is as compared to solid is low. But in if I'm taking the water, there is an anomalous behavior by ice that is having low density as compared to water, because in case of ice, volume increases and density decreases, which is responsible the floating of ice over the liquid water over there is present. But in nature, mostly it happens that solid remains in the base over there. If I'm going to melt or heat up anything, solid will remain as the base over there. Solid will not be converted into liquid in that case over there. Okay, so this is the way how to calculate the density of regular and irregular objects over there. After that, I will move towards pressure over here, which I will say pressure is force per unit area is called pressure. If I go for here, pressure. Pressure is named as force acting normally per unit area is called pressure, and pressure is equal to force applied normally over area, having formula P is equal to F over A. It is a scalar quantity, and its unit is Newton per meter square. And if we go more in detail, then atmospheric pressure we mostly take into account. 1 atm is 101,300 Newton per meter square should be taken as atmospheric pressure over there at sea level. If I look towards this formula, then I will say P is equal to F over A describes that pressure is directly proportional to force applied. It means if I keep my area constant and I increase the force, then pressure is directly proportional to applied force. If I keep my force constant, but I increase the area, if area increases, then the pressure decreases. As like if I'm using a flat sole on the surface of earth, I am exerting less pressure as compared to if I use pin heel shoes over there, like pin heel like that, then it means that heel is touching the surface area very small over there. In that case, I will say pressure will increase as the area is decreasing over there. So this is the inversely and directly proportional relationship between pressure and force over there, and inversely proportional to pressure and area over there. So in both of these cases, you will have to keep in mind what you are increasing and how pressure will behave over there. And this can also be used according to Pascal's law, which describes that when a pressure is exerted on a liquid, it is completely transferred into the next quantity without any change, without any loss over there. And in that case, we take the relation F1 over A1 is equal to F2 over A2. It means if I say like this, that I am increasing the pressure over there in this form, that it is going to be taken as like, for example, I'm saying here, I am applying the brakes. My foot is exerting, let's suppose I say 10 Newton over 2, I say over 2 centimeters square, like that. On the other end, I am saying I'm getting the 5 Pascal over there. And the other one, I am saying I am getting here that area is being distributed to all 4 tires with the force of 1000 Newton with the area of 200 centimeters square, like that. In that case, I will say here that the pressure is again 5 Pascal. So overall, it is a scalar quantity. It is going to show, this is called Pascal's law, by the way. Pascal's law over there. So it is basically, we can say, the relationship which is going to be taken into account when I am talking that hydraulic press over there, or something else which we take mostly in account when we are talking about pressure is controlling, or if we go to the new cars showroom over there, we mostly observe that the cars are standing at first floor, second floor, third floor, even though there is no proper roads track for taking to in that plaza over there. So he is using hydraulic press over there. If we go to car wash and we see that the car is hanging and our car is being lifted up with the help of this hydraulic press, crane operator is operating in that phenomenon. Disc brakes are applying in this phenomenon. So this is the way how hydraulic press is going to be controlling by that value over there. And if I say pressure in liquids, then we take in this form, let's suppose there is a liquid present in a container over there, and you are taking a body dipped here in this form, like that. Then how we say what is the density of this liquid over there? Then we use the formula P is equal to rho GH. Rho is the density of the liquid, G is the gravitational acceleration, and H is the height of the liquid or depth of the liquid over there. And if I say I want to take the upthrust, the force which is responsible for swimming purposes, for floating purposes of any object over the surface of liquid over there, then we say, how can we get that? I'm replacing this pressure formula with F over A is equal to rho GH, and F is equal to rho GAH. And I know area into height can be taken as volume. So I will say that upthrust force is equal to rho G and A multiply H. I'm replacing it with volume. Then I will say it is rho G V over there. So I think so. This is the formula which is providing a submarine to come on the surface, and when weight is less and upthrust is high. And on the other hand, when submarine is going downward, it means weight is high and upthrust is less, which is required for swimming purposes or floating purposes of dead objects over there. How they float on this, how they drone over there, and both are should be taken into account. So this was our today class. Tomorrow I will go towards center of gravity, moment, center of mass, and some equilibrium conditions also. I will go towards that topic. And for today, you are being introduced with the mass, weight, density, and pressure. So revise all the concepts and formulas over there and try to understand. We will manipulate them in topical questions over there. And this section is having 3 to 4 MCQs question related to it, and 80% chances are there that they are having 5 to 8 marks question in your paper too also. So be prepared, and thank you so much for today. Kindly subscribe my channel and support me. Thank you so much. Being your teacher, I will try my best to upload as much as high quality lectures as much I can do over there. Thank you so much. Allah Hafiz.